So now it's coming the parallelism in case of softwares, where it actually plays by the programming. And how to achieve this? There is no silver bullet. You have to think by yourself. You have to have your own logic. You have to know what is parallel algorithm, how the problem should be solved in a parallel mode, whether it can be solved in parallel mode or not, because all the problems cannot be solved in parallel. So you must have a better language. You have to have better compilers, okay, library files and everything, tools for checking, correcting everything, because writing these parallel applications are typically tough. It requires lots of programming effort and algorithmic changes in your mindset, that earlier whatever the programmers are trained, they are trained to write sequential programs, but because of the hardware changes, you are now required to be trained to write parallel programs if you want to go for the optimization of your performances. So here is the picture of parallel programming comes into issue. What we can do for? We can extend the compilers that will write sequential program, but the additional burden will be given to the compiler that it will translate which part can be done in parallel, which part can be done in sequential way. The entire responsibility goes to compiler, but that is very bad approach. Extend another language, existing language, that you have some existing operations, add some parallel operation on that. Or you add a parallel language layer on the top of the sequential language to look it like a parallel language. Or the best way is you redesign programming languages also and the compilers also, so that we can write the parallel programs in a newer way. What are the current status? That low-level approach is very most popular, that you have to apply your own logic for writing the parallel. Don't give the responsibility to the compiler, because compiler is also written by someone. So that may not be intelligent enough to identify which part can be done in parallel, which part can be done in sequential. So you understand the problem better. You decompose your algorithm and you write the program yourself. Don't give the burden of identifying which part can be given to the compiler for identifying the parallelism. So disadvantage of this is it's very difficult and to write the programs and debug. But from efficiency point of view and from portability point of view, this is the best option, that you write your own parallel programs. So as we have seen, we have two kinds of memory architectures primarily, shared memory and distributed memory. Shared memory, as the memory is shared by all the processors, it's like that you have one table having lot many foods all together, veg, non-veg, and you sit in the four corners, and which one likes by anyone, he can take from the same table, but all the foods remain on the same table. So it's accessible by all the CPU when the data or instruction is in the memory. And this kind of memory model, if the system is having, then we should go for thread kind of approach, multi-threading programming for writing parallel programs. And there are two such standards. One is POSIX, okay, or pthread even called, and OpenMP, through which we can write this shared kind of parallel programming. But make sure that this kind of approach, one, you cannot change the memory from your machine. So these machines are not scalable enough. Tomorrow you have some money, you purchase one CPU and you want to attach with your existing parallel machine. So this is not possible. So rather, all the systems are coming like that cluster computers. And these are distributed memory kind of. You purchase one memory slot, one RAM, you insert in your PCI slot on the motherboard, you purchase one CPU, or you purchase another motherboard, you take some additional memory, additional processor, keep on plugging in the network system. So your system will keep on increasing day by day in size and from performance point of view. So all the cluster computers are generally distributed from memory point of view. And when this is the case, it means like there is one table with food where you have the vegetarian foods, another table where there is some kind of sweets, another table where there you have non-veg foods. So if you are sitting in a table, you want some food that is in other table, then the food has to travel from that table to your table via some mechanism. Either you have to go and put in your plate, or that food should be transferred to your table, so physical exchange of data will be there because they are residing into two different distinct memories. And to write parallel program for this kind of memory architectures, we have either PVM or MPI, and MPI is preferred over PVM, and MPI stands for message passing interface. And there are two approaches of programming even. One is SPMD, single program multiple data. Another is MPMD, multiple program of multiple data. So you follow the images. In SPMD, all the CPUs are executing the same program, abc.c. Whereas in case of MPMD, all the CPUs are working at the same point of time, but they have different programs in their memory. And this kind of things, MPMD writing programs is much more complicated because they had to communicate among themselves to exchange the data. And the programs are different. One computer 1 or CPU 1 is executing program 1, CPU 3 is executing program 5 or something like that. So different programs. So that's why it's called multiple program, multiple data. And whereas in case of SPMD, you write one program, the same program will execute with all the CPU, but each and every CPU will know which part is for me. Out of all the programs, I will execute only this part. The remaining part I will not get executed. So we'll follow SPMD model of parallel programming. Using MPI,